Hi dear students, ನಾನು ನಿಮ್ಮ ಪ್ರೀತಿಯ ಗುರುರಾಜ್ ನಾಯಕ್, ನಿಮ್ಮ ಫೇವ್ರೆಟ್ ನಮ್ಮ ಕೆಮಿಸ್ಟ್ರಿ ಚಾನಲ್ಗೆ ಸ್ವಾಗತ. ಸೊ ಇವತ್ತಿನ ಈ ಒಂದು ಕ್ಲಾಸ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಿಸ್ ಕ್ಲಾಸ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್, ರೈಟ್? ಸೊ ಇನ್ ದಿಸ್ ಕ್ಲಾಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ರಿಗಾರ್ಡಿಂಗ್ ದಿ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ. ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಅಂದ್ರೇನು, ಯಾವುದೆಲ್ಲ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿಯನ್ನು ಕಲಿಬೇಕು, ರೈಟ್? ಸೊ in which type of unit cells we have to learn the packing efficiency. So ಮೂರು ಯೂನಿಟ್ ಸೆಲ್ಲಲ್ಲಿ ಕಲಿಬೇಕಾಗಿರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ HCP or CCP. ಜನರಲಿ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ದಟ್ ಈಸ್ FCC, ಫೇಸ್ ಸೆಂಟರ್ಡ್ ಯೂನಿಟ್ ಸೆಲ್ಲಿನ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ. ಆ್ಯಂಡ್ ದೆನ್ ವಿ ಹ್ಯಾವ್ ಟು ಗೋ ಫಾರ್ ದಿ ಬಾಡಿ ಸೆಂಟರ್ಡ್ ಕ್ಯೂಬ್ of that packing efficiency and the simple cube. So adraddu kuda packing efficiency find out madbekagirutte, right? So in the earlier classes we have learned regarding the close packer structure. So close packer structure andrenu one dimensional and then two dimensional matte three dimensional entire crystal lattice we have learnt, right? So but what happens in crystal lattice, if you take three-dimensional structure, right? So we are having what? Ovoids. So clearly we are having ovoids. They are nothing but tetrahedral ovoids or the octahedral ovoids. So these are what we are calling empty space present in particular crystal lattice. But right, so each cube has its own volume, right? So that volume is occupied by what? The spheres, right? For example, so we can take general example, right? So on the box irutte, so box in a volume anna tagolli, so we can calculate so volume of the box, right? So ivaga ಏನು ಮಾಡ್ತೀವಿ ಕೇಳಿದ್ರೆ ಅದಕ್ಕೆ ಲಡ್ಡು ಹಾಕ್ತೀವಿ, ರೈಟ್? ಸೊ ಉಂಡೆ ಇರ್ಬೋದು, ಲಡ್ಡು ಇರ್ಬೋದು, ಸೊ ಲಡ್ಡುವನ್ನು ಹಾಕ್ತೀವಿ, ರೈಟ್? ಸೊ ಲಡ್ಡು ಏನಿದೆ ಇವಾಗ, ಸೊ ನಿಮ್ಮ ಬಾಕ್ಸ್ ಒಳಗಡೆ ಇದೆ. ಸೊ ಬಾಕ್ಸಿನ ವಾಲ್ಯೂಮ್ ಎಷ್ಟು? ಸೊ ಯು ಕ್ಯಾನ್ ಫೈಂಡ್ ಇಟ್ ಔಟ್ ಎ ಕ್ಯೂಬ್. ಸೊ ಎಜ್ ಲೆಂತ್ ಎ ಆದರೆ ಎ ಕ್ಯೂಬ್ ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. ಹಾಗಾದರೆ ಲಡ್ಡುವಿನ ವಾಲ್ಯೂಮ್ ಎಷ್ಟು, ರೈಟ್? ಸೊ ಎಷ್ಟು ಲಡ್ಡು ಹಾಕಿದ್ರಿ ಅದರ ವಾಲ್ಯೂಮನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. ಹಾಗಾದರೆ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಅಂದ್ರೇನು? ಸೊ ಇವಾಗ ಎಂಟಿ ಬಾಕ್ಸ್ ಇದೆ, ಆ ಎಂಟಿ ಬಾಕ್ಸ್ ಒಳಗಡೆ ಲಡ್ಡನ್ನು ಹಾಕಿಟ್ಟಿದ್ದೀರಿ. ಸೊ ಆ ಎಂಟಿ ಬಾಕ್ಸಿನ ವಾಲ್ಯೂಮಲ್ಲಿ ಎಷ್ಟು ಲಡ್ಡುವಿನ ವಾಲ್ಯೂಮ್ ಇದೆ, right? What is the percentage of total space filled by that laddus inside that box? Clear? So the same way, so now we can go for what? A cube. It may be what? The FCC, face centered, or else it may be the body centered, or it may be the simple cube, right? So a cube na tagoli, how many atoms are present? Just take that and keep it inside the box. Now you can calculate, so what is the volume of that box or else a cube, and what is the volume of the sphere? How many spheres are there? So multiply the volume of that each sphere, right? So same irutte, size same irutte, adrinda so equal agi navu ಏನು ಮಾಡಬಹುದು? Multiply ಮಾಡುವಂತದ್ದು, right? So now first we will go for the packing efficiency in HCP and CCP structure. So very very important. So all the three things are very very important. So 3 marks ಗೆ ಡೆಫಿನೆಟ್ ಆಗಿ ಬರುವಂತ ಕ್ವೆಶ್ಚನ್ಸ್ ಇದು, ಅದರಿಂದ ಕರೆಕ್ಟ್ ಆಗಿ ಇದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ. ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಇನ್ HCP, ಹೆಕ್ಸಾಗನಲ್ ಕ್ಲೋಸ್ ಪ್ಯಾಕ್ ಅಂದ್ರೂ ಒಂದೇ, ಅಥವಾ CCPಯ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಕೂಡ ಏನಾಗುತ್ತೆ? ಒಂದೇ ಆಗುತ್ತೆ. ಸ್ಟ್ರಕ್ಚರ್ ಇಸ್ ಡಿಫ್ರೆಂಟ್. HCP ಸ್ಟ್ರಕ್ಚರ್ ಬೇರೆ, ಹೆಕ್ಸಾಗನಲ್ ಕ್ಲೋಸ್, ರೈಟ್? ಹೆಕ್ಸಾಗನ್ ಇರುತ್ತೆ. CCP ಬೇರೆ, ಅದು FCC ಕ್ಯೂಬ್ ಆಗಿರುತ್ತೆ, FCC ಆಗಿರುತ್ತೆ, ರೈಟ್? ಬಟ್ ಏನಾಗುತ್ತೆ ಕೇಳಿದ್ರೆ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಇನ್ HCP ಆ್ಯಂಡ್ CCP ಬೋತ್ ಆರ್ ಸೇಮ್. ಎರಡೂ ಕೂಡ ಏನಾಗುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ. ಬಟ್ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಟು ಗೋ ಫಾರ್ ವಾಟ್? CCP ಆರ್ ಎಲ್ಸ್ ಬೈ ದ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಏನು ಮಾಡ್ತೀವಿ ನಾವು ಅದನ್ನು FCC ಅಂತ ಹೇಳ್ತೀವಿ. CCP ಏನಿದೆ ನೋಡಿ, ಕ್ಯೂಬಿಕ್ ಕ್ಲೋಸ್ ಪ್ಯಾಕ್ ಏನಿದಾವೆ ನೋಡಿ, ಅದರ ಯೂನಿಟ್ ಸೆಲ್ ಯಾವುದಾಗಿರುತ್ತೆ ಕೇಳಿದ್ರೆ ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ FCC. ಸೊ FCCಯನ್ನು ತಗೊಳ್ಬೇಕು, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ ಮೂವಿಂಗ್ ಅಹೆಡ್, let us calculate the efficiency of packing in CCP structure. So you can see the diagram. So diagram ana kottidene. So just see the diagram. We have what? Face centered cube, FCC are there, but only the 3 spheres are there. So that is enough for us. Remaining sphere, it is there, but for our convenience we have taken what? For our understanding, so we have taken what? 3 spheres only. That is the particular way in face centered, face diagonal. You can say it is face diagonal, right? So in diagram, so let the unit cell edge length should be A, right? So unit cell in edge length ಏನಾಗಿ ತಗೊಳ್ಬೇಕು? A ಆಗಿ ತಗೊಳ್ಬೇಕು. And the face diagonal, so what is that face diagonal? So you can see in a diagram clearly, AC ಇದೆಯಲ್ಲ, A to C ಏನು ಡ್ರಾ ಮಾಡಿದ್ದೀರಿ ನೋಡಿ, ಅದನ್ನು ಏನು ಹೇಳ್ತೀವಿ ನಾವು? ಅದನ್ನು ಫೇಸ್ ಡಯಾಗ್ನಲ್ ಅಂತ ಹೇಳ್ತೀವಿ, ರೈಟ್? ಸೊ ರಿಮೆಂಬರ್ ಇಟ್ ಈಸ್ ಫೇಸ್ ಡಯಾಗ್ನಲ್, ರೈಟ್? ಸೊ ದ ಲೆಂತ್ ಆಫ್ ಫೇಸ್ ಡಯಾಗ್ನಲ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ವಾಟ್? AC. ಸೊ ಆ ACಯನ್ನು ಏನು ಹೇಳ್ಬೋದು ನಾವು? ಅದನ್ನು B ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು, ರೈಟ್? ಸೊ ಇನ್ ಎ ಟ್ರಯಾಂಗಲ್ ABC, right? So in a triangle ABC, right? So why we have to take that triangle ABC? So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಕೇಳಿದ್ರೆ very simple. So we have to find out that volume for out the volume of the unit cell. So unit cell in a volume ಅನ್ನು find out ಮಾಡಬೇಕು first ಗೆ. So unit cell volume, so if you know the edge length, all edges are equal, hence you can say it is a cube. So easily ಏನು ಮಾಡಬಹುದು ಅದನ್ನ a cube ಅಂತ ಹೇಳ್ಬಹುದು, right? So now we have to calculate what? Next we have to calculate what? The volume of the each sphere. So sphere in a volume ಅನ್ನ find out ಮಾಡಬೇಕು. So sphere in a volume ಅನ್ನ find out ಮಾಡಬೇಕಿದ್ರೆ, so we must know what? Radius. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ರೇಡಿಯಸ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಹಾಗಾದ್ರೆ ಆ ರೇಡಿಯಸ್ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡುವಂಥದ್ದು, ಅಥವಾ ಆ ರೇಡಿಯಸ್ ವ್ಯಾಲ್ಯೂನ ಎಲ್ಲ ಹಾಕ್ಬೋದು, ಆರ್ ಎಲ್ಸ್ ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್ ಇಟ್ ಔಟ್ ವಾಟ್? ಎ. ಸೊ ಎ ನ ವ್ಯಾಲ್ಯೂನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು, ಅಥವಾ ಆರ್ ವ್ಯಾಲ್ಯೂನ ಕೂಡ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. ಸೊ ಜಸ್ಟ್ ಯು ಕ್ಯಾನ್ ಸಿ ದೇರ್. ಓಕೆ, now let us take an ABC. So why we have taken ABC? Because the radius is related to that edge length. So length ಗೆ ಏನಿದೆ ನೋಡಿ, face diagonal ಏನಿದೆ ನೋಡಿ, so that is a relationship you can get it from what? The triangle ABC. So ABC ಅನ್ನ ತಕೊಂಡು ಏನು ಮಾಡ್ಬೋದು, ನಮಗೆ ಅಲ್ಲಿರ್ತಕ್ಕಂಥ ರೇಡಿಯಸ್ ಯಾವುದು, ಮೂರು ಸ್ಪೇರಿನ ರೇಡಿಯಸ್ ಎನ್ನುವಂಥದ್ದು ಏನಾಗುತ್ತೆ, ಫೇಸ್ ಡಯಾಗ್ನಲ್ಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದೇರ್, ರೈಟ್? ದ ಫೇಸ್ ಡಯಾಗ್ನಲ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ the radius of all that three spheres. So sphere, first sphere ina ಒಂದು ರೇಡಿಯಸ್, ಸೆಕೆಂಡ್ ಸೊ ಮಿಡಲ್ ಇರ್ತಕ್ಕಂಥ ಫೇಸ್ ಸೆಂಟರ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಒಂದು ಸ್ಪಿಯರ್ ಇನ ಎರಡು ರೇಡಿಯಸ್, ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದೇರ್. ಸೊ ಟೂ ರೇಡಿಯಸ್, and then final at the end whatever you have the radius of that sphere. So totally how many radius we are getting in that B? So we are getting 4 radius. Then we can get the relationship. Okay, so before going to that, just see here. Now what is a B? So you can find out the B or else AC, right? So in triangle ABC, right, according to Pythagoras theorem, you can see AC square is equal to what? AC square is nothing but what? B square. Clear? AC square is equal to B square. That is equal to, right, BC square plus AB square. ಅರ್ಥ ಆಯ್ತಾ? So AC square is equal to BC square plus AB square. So now you can say AB and BC are nothing but what? Edge length A, all are, both are equal. Hence what happens? BC square is equal to A square and AB square also is equal to what? A square. So that's why AC square is equal to what? A square plus A square, that is equal to what? 2A square. So ಏನು ಬರುತ್ತೆ ನಮಗೆ? ಸೊ 2A square ಬರುತ್ತೆ. ಅದರಿಂದ AC square is equal to 2A square, or else you can say it is B square is equal to 2A square. Right, so you can observe then. So ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ, B square is equal to 2A square, or B is equal to, so B is equal to what? root 2 into A ಅಂತ ಹೇಳ್ಬೋದು. ಸೊ B is equal to root, ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಗುತ್ತೆ ಅಲ್ವಾ? ಸೊ ಅದರಿಂದ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ 2 into A ಅಂತ ನಾವು ಅದನ್ನು ತಗೊಳ್ಬೋದು, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಗೋ ಫಾರ್ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ವಾಟ್? ರೇಡಿಯಸ್ ಆ್ಯಂಡ್ ದಿ ಬಾಡಿ ಡಯಾಗ್ನಲ್. ಬಾಡಿ ಡಯಾಗ್ನಲ್ಗೂ ಮತ್ತು ರೇಡಿಯಸ್ಸಿಗೂ ಸೊ ಏನು ರಿಲೇಶನ್ಶಿಪ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ನಾವು ಯು ಕ್ಯಾನ್ ಸಿ ಇನ್ ದಿಸ್ ಡಯಾಗ್ರಾಮ್, ಇಫ್ R is the radius of the sphere, right, R is the radius of the sphere, so we find what is that B. So B is equal to how many radius? So clearly you can see B is equal to 4R ಅಲ್ವಾ? ಸೊ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ನೋಡ್ಬೋದು B is equal to 4R. ಸೊ ಫಸ್ಟ್ ಸ್ಪಿಯರ್ ಇನ ರೇಡಿಯಸ್ ಪ್ಲಸ್ ಸೆಕೆಂಡ್ ಸ್ಪಿಯರ್ ಇನ ಎರಡು ರೇಡಿಯಸ್, ರೈಟ್? ಸೊ 2 ರೇಡಿಯಸ್. ಅಟ್ ದ ಎಂಡ್ ವಿ ಹ್ಯಾವ್ ಒನ್ ಮೋರ್ ರೇಡಿಯಸ್. ಟೋಟಲ್ ಯು ಹ್ಯಾವ್ 4 ರೇಡಿಯಸ್. ಸೊ ದಟ್ಸ್ ವೈ ಯು ಕ್ಯಾನ್ ಸೇ ದ 4R is equal to what? B is equal to 4R, and that 4R is equal to what? root 2A, right? So root 2A. So from that we can get what exactly A. So A ಅಂದ್ರೆ ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. ಅದರಿಂದ A ಏನಾಗುತ್ತೆ ನಮಗೆ? 4R ಅಲ್ಲಿದೆ ನೋಡಿ, 4R and root 2A ಇಂದ A is equal to what? root 2 ಏನಾಗುತ್ತೆ? ಸೊ ಈ ಕಡೆ ಬರುತ್ತೆ ಈಕ್ವಲ್ ಮಾರ್ಕಲ್ಲಿ. ಆಗ ಏನಾಗುತ್ತೆ ನಮಗೆ? A is equal to 4R divided by root 2, right? So then you can rewrite that 4. So 4 you can rewrite in this fashion. How? So 4 you can rewrite as it is. ಮೇಲ್ಗಡೆ 4 ಇದೆಯಲ್ಲ, ಸೊ 4 ಯಾವ ರೀತಿ ಬರಿಬೋದು? ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥದ್ದು 2 into root 2 into root 2, you can write it, that is equal to 4, right? 2 into root 2 into root 2, that is equal to 4, you can write, right? So root 2 and root 2 get cancelled, right? Denominator and numerator root 2 get cancelled, and remaining things are what? 2 into root 2, right? 2 into root 2 into r. Clear? See there, 2 into root 2 into r, right? So we can also rewrite with the relationship with r. So r we can write, right? A is equal to, so a is equal to 2 root 2, right? 2 root 2 into r. A is equal to 2 root 2 into r, and then r is equal to what happens? R is equal to, r is nothing but a divided by 2 root 2. R is equal to a divided by 2 root 2. Simply we can say, right? So r is equal to a divided by 2 root 2, right? So next, we know that, so each unit cell in CCP structure has efficiently how many sphere? 4 sphere. So CCP ಅಂದ್ರೆ ಏನು? is nothing but FCC. ಎರಡು ಒಂದೇ ಅದು, ಆಯ್ತಾ? FCC. So ಅದರಿಂದ ಏನಾಗುತ್ತೆ ಕೇಳಿದ್ರೆ, what is the total number of atoms present in FCC? That is nothing but 4, right? 4 ಹೇಗಾಗುತ್ತೆ? 6 faces in the half contribution, 6 into half we are getting 3, and 8 corners 1 by 8 into 8, that is 1. So totally how many spheres are there? So totally 4 spheres are there, right? So then has efficiently 4 spheres. Total volume of a 4 sphere is equal to, so what is the volume of a sphere? So sphere in a volume enagutte, it is nothing but 4 divided by 3, 4 by 3 pi r cube, right? 4 by 3 pi r cube. Hagadre how many atoms are there? So how many atoms are present there? So 4 atoms are present. So hence 4 into 4 by 3 pi r cube is nothing but volume of the what? 4 spheres. Clear? And then what about the volume of the cube? Volume of the cube is nothing but a cube, right? So a cube, or else you can rewrite a cube. A andre no, so nodidiri a andre, so a is nothing but what? 2 into root 2 into r, right? Hagadre a cube enagutte? A cube is nothing but 2 root 2 r bracket haki to the power estagutte namge 3, or else you can say it is cube. 2 root 2 r cube, whole cube anta helbodu, right? So now therefore, so what exactly the packing efficiency? So packing efficiency andre no, so what is packing efficiency? Very simple. What? The total volume of the unit cell, we know that. So how many volume is occupied by the sphere? That's it. So adrinda enu helbodu, volume occupied by the 4 spheres in that unit cell divided by a total volume of the unit cell, right? So total volume of the 4 sphere in unit cell divided by the total volume of the unit cell, right? The efficiency, packing efficiency we are calling, so that is you have to multiply by 100, so percentage, right? So we are calling in percentage into 100. So then what happens? So we can so write down that, so volume of the 4 spheres, so what happens? 4 into, right? 4 into 4 by 3 pi r cube, right? So pi r cube, 4 by 3 pi r cube into 100 divided by, what is the total volume of the unit cell? It is nothing but 2 root 2 r whole cube, right? So then you can simplify ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ನಮಗೆ 16 divided by 3 pi r cube, right? 16 divided by 3 pi r cube divided by 16 into root 2 r cube. So ಆ ಕ್ಯೂಬ್ ಅನ್ನ ಒಳಗಡೆ ತಗೊಬನ್ನಿ, ಆವಾಗ so you can simplify it and then percentage. So finally we are getting what 74%, right? So 74% is nothing but the packing efficiency where in the case of FCC. So you can say it is Hcp or Ccp. Very very important. They may ask the questions, find out the packing efficiency of Hcp, find out the packing efficiency in the Ccp, right? Find out the packing efficiency in FCC. So for that 3 questions you have the same answer. Clear? So it is nothing but 74%, you can see here, right? So once again go back and just see, very very important, right? So you can solve that yourself, you can solve it, okay? So this is exactly what the packing efficiency in FCC, right? So next, moving ahead, packing efficiency of the body centered cubic structure, right? So body centered cubic structure. So here also same thing, same approach we have to go, right? So we have to take what? The body centered unit cell, right? So how many atoms are present? That also you should know, right? How many atoms are there in body center? Total you have what? two things. So two atoms are present, but you can write the unit cell and draw it. So see here, so this is what exactly the body centered cubic unit cell, right? So for our convenience we are going to take what, only the body diagonal. Body diagonal. So before we have done with the face diagonal is different, body diagonal is different. So why we have to take that body diagonal? Because so in that radius relations we have to take. So what is that radius with the body diagonal? So where that atoms are going to touch in the there, what in face diagonal also we have seen all the atoms are touch each other, where it is exactly at the face center, right? So here atoms are going to touch where exactly the body center. So in that body center all the atoms become what, they are touched to each other. So hence we can take that body diagonal to give what, relation with R and A. So A ಗೆ ಮತ್ತೆ R ಗೆ relation ಬೇಕಾಗುತ್ತೆ, ಅದನ್ನ ನಾವಲ್ಲಿ ತಗೊಳ್ಳುವಂತದ್ದು, right? So in the diagram you can see, so we can take that body diagonal. And then what is that body diagonal? So body diagonal ಅಂದ್ರೆ ಏನು? So ಗೋಡೆ ಇರುತ್ತೆ ಅಲ್ವಾ, so just take room. ಸೊ ವಾಲ್ ಇರುತ್ತೆ ಅಲ್ವಾ, ಸೊ ಗೋಡೆ ಒಂದು ಕಾರ್ನರ್ ಇದ್ರೆ, ಸೊ ಇದು ಕಾರ್ನರ್ ಆದರೆ ಅದರ ಅಪೋಸಿಟ್, ಸೊ ಅಪೋಸಿಟ್ ಲೈಕ್ ದಿಸ್, ಅಪೋಸಿಟ್, ರೈಟ್, ಅಪೋಸಿಟ್ ಆಗಿ ಇರಬೇಕು ಅದರದ್ದು ಅಪೋಸಿಟ್ ಕಾರ್ನರ್, ಅಂಡ್ ದಟ್ ಈಸ್ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಬಾಡಿ ಡಯಾಗ್ನಲ್. ಯು ಕ್ಯಾನ್ ಸಿ ಹಿಯರ್, you can see in that picture. So that is exactly what so body diagonal, right? Now so here we have to take what, the edge length is nothing but A. So consider the edge length is A, right? So now directly we are not going for the body diagonal. So body diagonal value ಅನ್ನು direct ಆಗಿ ನಮಗೆ ತಗೊಳ್ಳಿಕ್ಕೆ ಆಗಲ್ಲ. So we have to first apply the simple triangle in EFD, right? So draw like that only, take ABC like that only, okay? In this diagram you can observe. So from that, so we are going to draw, okay? In triangle EFD, so in triangle EFD you can see, so in downside you can see, just I have marked there, so that is triangle EFD. So in that case what happens, B square is equal to, B square is nothing but what, right? So B is the diagonal here, so B is the diagonal of the triangle EFD. So B square is equal to A square plus A square equal to what, 2A square. Clear? B square is equal to 2A square. So you can see in diagram, right? So then B is equal to what, B is equal to root 2 into A, right? So root 2A, right? So next we have to go for what, in triangle AFD. So AFD triangle you can see, in triangle AFD. So what happens now, C square is equal to, C square is equal to addition of what, A square plus B square, right? So C square is equal to A square plus B square, right? So now what is A square? So A square is nothing but what, the same thing, A square, right? So and what about the B square? So B square already we have find it out, B we have find it out, and then what about B square? B square is nothing but what, root 2A whole square, right? So then what happens, we are getting what, B square is nothing but 2A square, B square is nothing but 2A square, A square same as it is, right? So B square is equal to 2A square. So then you can see, clearly see, C square is equal to A square plus B square, it is equal to what, A square plus 2A square, right? So A square plus 2A square, total how much we are getting, C square is equal to 3A square, you can observe there, 3A square, and then C is equal to what, C is equal to, so root 3 into A, right? So root 3 into A, right? So now we can get the relationship between what, that radius and the body diagonal. So what is that body diagonal is equal to how many, radius. The length of the body diagonal C is equal to, once again that is equal to 4R. You can observe there. So how many spheres are there, 3 spheres are there. So right, contribution, the first and last sphere 1 radius, and the center, the body center sphere has the 2 radius, which is contributed for that body diagonal. Totally how many radius, 4 radius, where R is the radius of the sphere in an atom, as all the 3 spheres along in the diagonal attached to each other. So that's why we are choosing that particular diagonal. So therefore you can say root 3A is equal to what, root 3A is equal to 4R, right? So we can relate that. ರೂಟ್ 3a ಅನ್ನುವಂಥದ್ದು ಏನಾಗುತ್ತೆ ನಮಗೆ 4r ಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ a ಅಂದ್ರೇನು ಎಡ್ಜ್ ಲೆಂತ್. ಸೊ a ಅನ್ನುವಂಥದ್ದು ಏನಾಗುತ್ತೆ ನಮಗೆ 4r ಡಿವೈಡ್ ಬೈ ರೂಟ್ 3. The 4r divided by root 3 is equal to what? A, right? So from that we can get the relation of r. So r also we can find it out. So r is nothing but what? Root 3 divided by 4 into a. So root 3 divided by 4 into a, right? So then now we can find out what? The total number of atoms. So how many total number of atoms present in your BCC? So it is nothing but 2. And what about that volume of that 2 sphere? So the volume of each sphere, that is equal to 4 by 3 into pi r cube. Hence you can multiply by what? 2. ಅದರಿಂದ ಏನಾಗುತ್ತೆ ನಮಗೆ 2 into 4 divided by 3 into ಏನಾಗುತ್ತೆ pi r cube. So that is the volume of what? 2 spheres, right? Now, so volume of the cube is nothing but what? A cube. So ಹಾಗಾದ್ರೆ a ಅಂದ್ರೆ ಏನು? So what is that? A is nothing but 4r divided by root 3. We know that, right? So substitute that value a cube in a cube. So that's why what happens? 4 by root 3 r whole cube, right? 4 under root 3 r whole cube, that is equal to a cube. Clear? So a cube, right? So next, what about the packing efficiency? Same thing. What is that packing efficiency? Volume occupied by 2 spheres in a single unit cell divided by total volume of the unit cell into 100. That is the percentage you are getting. Just simplify that values, and so put that value, volume of the 2 spheres in that particular unit cell, 2 into 4 by 3 pi r cube, clear, divide by the total volume of the unit cell is nothing but 4 divided by root 3 r whole cube, right? Simplify it, then you are getting what? 8 by 3 pi r cube into 100 divided by 64 divided by 3 into root 3 r cube. That is equal to, finally you are getting, after simplifying that, it is equal to 68%, right? 68%. So now you can see difference between what? FCC and the BCC. So which one has the more efficient? Yaudu more efficient agirutte? Quite what? Which one? 74%. So that is in FCC, right? So that is the packing efficiency what? FCC. But so here BCC you have a little bit less, that is to 68%, right? At the last we have what? The simple cube, right? Simple cubic lattice. So in the simple cubic lattice you can see the diagram. So that is a simple cubic. For our understanding, so we can take only the, for relationship between what? Edge length and the radius, you can choose any 2 spheres, right? Any 2 spheres of that corners, right? So we have to assume that the each sphere is touched to each other. Length of the side of the cube equal to what? A, we know that. And the radius of each particles r is related as with the your edge length. That's why a is equal to what? A is equal to 2r, right? Edge length a ಅನ್ನುವಂಥದ್ದು ಏನಾಗುತ್ತೆ? 2 radius ಗೆ equal ಆಗುತ್ತೆ, 2 into r, right? So now what is the volume of the cubic unit cell? So volume of the cubic unit cell is nothing but a cube, right? We know that a is equal to what? 2r. Then what about the a cube? A cube is nothing but 2 into r whole cube. So that is equal to what? 8 into r cube. So you can see there 8 into r cube. Since a simple cubic unit cell contains how many atoms? Only 1 atoms. You can see there only 1 atom is present. The volume of occupied by the space, the volume of the occupied space, that is equal to what? You can see here, sorry, the volume of the occupied by the sphere. So what is the volume of sphere in that particular unit cell? It is nothing but only 1 sphere is there. So that's why the volume of that sphere is nothing but what? The same formula, 4 by 3 pi r cube, 4 by 3 pi r cube. So now you can go for the what exactly the packing efficiency? Packing efficiency, same thing, what? Volume of 1 atom divided by what? Volume of the cubic unit cell. What is the volume of 1 atom? Is nothing but 4 by 3 pi r cube, you know very well. And what is the volume of the cubic cell? So that is a cube is nothing but 8 r cube, so 8 r cube, right? So into 100 you are getting. Then what happens? Pi divided by 6 on simplifying, pi divided by 6 into 100 you are getting, from that you are getting what? Efficiency, that is 52.36 percentage, nearly is equal to 52.4%. Thus we may conclude that CCP HCP structure have maximum packing efficiency compared to the body centered and the simple cubic. So these are the things regarding what? The packing efficiency, right? So this is very important. So ಮೂರಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಎಕ್ಸಾಮಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಸೊ ಆದ್ದರಿಂದ ಸೊ ಇವತ್ತಿಗೆ ಇದಿಷ್ಟನ್ನು ಕರೆಕ್ಟಾಗಿ ಕಲೀರಿ. ಸೊ ಜಸ್ಟ್ ಲರ್ನ್ ಇಟ್ ಇನ್ ಪ್ರಾಪರ್ ವೇ, ದಟ್ 3 derivations, or else you can say it is what. So it is very important. So derive yourself. So write it and practice it more and more. If you practice, you are getting what? Exact idea regarding that. Okay. So thank you so much.